Hello, welcome of all of you. Today I will talk about support vector machine or SVM. So support vector is initially developed in 1960, then it is refined in 1990. So this is very much popular due to the powerfulness compared to the other machine learning algorithm. So let's understood how support vector machine actually works. So here I will go through SVM basic, then some kernel tricks and some sample codes of SVM. So support vector machine. So how do we derive a line for separate? So how do we actually separate? Actually decision boundary is very important. So now how do we define a line for separate? How do we actually separate? Actually decision boundary is very important. So we start a new point adding in our classification purpose on this classification. So that new point should be either in an orange dot or in a blue dot. So how can you separate this point area? So here is a orange dot and blue dot is there, and according to that we have to make a line to separate this. So here we can put a line, then this red star is a new point, and here according to this scenario what will be it? Basically it is nothing but a blue dot. Or in this scenario, if it is, if I am talking about is this optimal, no, it may be a chance to create something. If I put a line over here, then maybe a chance to create is an orange dot, or I can put a line over here, or I can put a line over here, or I can put a line over here. So what will be the optimum one? So now I can say that there's one way to draw a line out of this space. Anything will be right in the orange dot and anything will be left in the blue dot. So we can draw this line in a different line, we can place it. Now finding the best line and that decision boundary which will use space into a separate our class. This line through a put maximum margin. A line draw from a equidistance. So this point actually called support vector. Which point? Now I'm gonna show you. So here I put a dotted line over here. So now this is a from this picture I can say that this line could be a maximum equidistance, is a maximum margin. So like that. So distance between these two lines will be m plus and m minus, and this red line I can say is an hyperplane, and these two dot are called support vector. So why it is called support vector? I come to this line, I come to this point. So hyperplane, and these are the margin m plus and m minus, these are the basically distance. So margin, hyperplane and support vector. So these are the very important topic. So now from here I can say that support vector are the data points that define the hyperplane and the maximum margin. So now as I say that why it is called the support vector, why it is called support. So these are the 2 points supporting the whole algorithm, and the other point doesn't contribute to the result of this algorithm. Only these 2 points are contributing, so that these are called support vector. These other points are not so much important over here right now. These are the 2 points very important, so that's why they are called support. And why it is called a vector? In multi-dimensional space we have just more than two, or here just 2, 5, 3, 10, 100 variables. So each point actually known as a point, because we cannot visualize on the 2D space, even in the 3D space, and therefore each point is seen. There is a considering actually vector in a multi-dimensional space. So in case of multi-dimensional space, these are not a data point, it is nothing but a vector. So these are the two pointers supporting decision boundary. So that's why it is called support vector, and that's why the algorithm is called support vector machine. Now what else we have to do? The line in the middle is called maximum margin hyperplane, or you can say that the maximum margin classifier. In a 2D space, we can say there's a classifier, but in multi-dimensional case, we have to say hyperplane. And the dotted line, we can say that it's a positive hyperplane and the negative hyperplane. Okay. So now, why? And another thing is that I'm gonna just go through the definition of this margin. Margin is distance from the decision surface to the closest data point determines the margin. And the hyperplane is the line or the plane that linearly separable classified a set of data. So now, why so special about SVM? So here is a picture of an apple and orange, and how a machine can understood whether it is an apple and orange. So from human, they can understood from human learning. We can say that some features, sort of features are there, and some level is there, one level also there. So what is that? Color, texture and taste is the features. So if I say that the red color and texture is smooth and taste is sweet, so I can say that it's an apple. And if it is, the color is orange and the texture is bumpy and taste is sweet and sour, so I can say it's an orange. From this human learning we can understood this. Now according to this point, so if I got this kind of color of an apple, or I can say that this kind of color of orange is there, so this may be also possible. So where these points are uh, actually lie, basically, if I understood these two problematic, because these are the problematic points, so I can easily, if this one is say that it's an apple, due to this color maybe wrongly maybe are classified, or in case of anything wrongly classified, or these are the points. So here it is depicted as this, all these green dot is all the oranges, and these red dot is all the apples. Okay, but these 2 points are, maybe this one is say that this point, or this apple color is, you know that this is not red, this is near about is orange. So this may point lie this in this segment. Okay. So now, so the previous slide we can understood that what is hyperplane, what is margin, and what is support vectors. Okay. So right now we're gonna go into a different approach, like the previous data are all the data linearly separable. That means if I put a if I any dimension there is a 2 points is there, we can linearly separable by draw a line. But somehow in this scenario, if some non-linear data is there, or not or it is not possible to linearly separable in 1D data set, then what should I do? There is a very easy thing is that if we change the dimension, then linearly, say not that those data are not linearly separable. So if we put it in a 2D, if it is there is a 1D, then if I convert it into a 2D, then there is a chance uh, to separate these two data points. So but there is a disadvantage. What is that? The mapping to the higher dimension is always can be a high compute intensive. So this is the solution of a kernel tricks. So I first go through that the 1D dataset visualization. Like here is a 1D data representation. Then I can change this data non-linearly separable. In these points you can see that this blue, this violet color and this red dot is a two different, but in any moment we cannot put a straight line between these. We cannot separate linearly properly, otherwise it is misclassified, right? So how what should I do? So we just converted into this particular segment into 2D format. In 2D format you can see that in here you can easily you can separable using, if we put a line between this segment to this segment, then you can easily separable these two data points, like simple like that. Okay, so now in 1D I converted into 2D for suppose. So here it is in hyperplane obviously. So now there is an another, so this is another 2D data example. Like when we converted into this particular segment, we converted into 3D, then this is the hyperplane, then we can easily solve this problem. So now where this kernel approach is there, so here we will actually, it's nothing but a mathematical approach. Using that mathematical approach, using in a 2D we solve this problem. Okay, so we will, how we will do this? So here is a function of a Gaussian RBF kernel. So there is a equation of kxy, and this is equals to exponential of minus x minus y square whole square. Basically it's a distance between x and y, and divided by 2 sigma square. So what is basically depicts, so here is a Gaussian representation. Like so p and q here is represent as a plane, and you know there is a different color is there. So blue color, then after that there is a color is changes, then green, then yellow, then red is there. So now you can see that this p and q is a to represent as a plane. Then I just taken as a line between from the top of that, and this blue red dot is the bottom. Basically this the middle of the whole p and q plane, this line, and this red dot is the bottom of the landmark from where we can measure the distance. From here we can measure the distance of any point which is lie between p and q surface. So here now we put another line, is a red dot is there. So now I have to measure the distance over here. So what is the distance between x and y? X minus y is the distance. Now the good part is that from the center, when the data point is very much far from here, the distance is increased, then it is divided by 2 sigma square. Then automatically the denominator will be uh, bigger and the upper one is lower. So automatically if we convert it into an exponential, then we can say that the distance is far from the landmark or the center, the value is near about 0. So if the distance is larger, then it is tends to 0. And similarly this another point which is much more nearer about this particular segment. So from here definitely this is the distance is low and the denominator is a big, then automatically the exponential value will be near about 1. So the distance between the landmark and the central, then the value will be near about 1. Okay, so and this the resultant will be the vertical axis representation, that is the resultant, that should be, we have to calculate it. So now we just showing you that the value of the sigma is a very significant. If the sigma value is increased, Suppose there is a I just represent as a data point which is non which is not possible to linearly separable. So now I can say that this is the value of sigma. If the sigma value is increased, if the sigma value is increased, then this is just going to up, and automatically it will represent this point will be much more. Here is a near about 1, and this other one will be the 0 part. So we can easily separable that's two data point from here. So here it is represent like that you know 2 point is there, one is a blue dot and then is a yellow. So in case of sigma is increased, then automatically this circumference will be smaller. And similarly the opposite one, if the sigma value is decreased, if the sigma value is decreased, then automatically if the sigma value is decreased, then automatically this segment is converted into this one. Okay, so from mathematical approach we can easily converted this from the higher dimension uh, very easily without hampering our computational approach, or we can say that using this mathematical approach we can easily solve this hyperplane problem. Okay, so now the types of kernel function. So here is a three very much popular, that the Gaussian RBF kernel, polynomial kernel, and sigmoid kernel. So here I am just not explaining all these things, but right now when we do any program, then in case of kernel we can change the value. In case of if I go through a linear, so kernel value will be linear. Then if it is Gaussian RBF kernel, so you can change the different kernel to get the very good result according to your problem. Okay, so now I'm going to there's an application part of this SVM. Application is a face detection. In SVM classify parts the image as a face and non-face to create a square boundary around the face like that. Okay, and you can say that in bioinformatics it includes a protein classification and cancer classification. So we can SVM for identifying the classification of genes, uh, patient on basic their uh, patient on basis their genes and other biological problems. So basically we can solve it. This algorithm also working very this algorithm is working in bioinformatics, very widely used. Okay, so classification based on structure, and classification based on the composition, and classification based on the function. So these are the part of a classification of protein. Okay, and so many genetic structure also classified by this particular uh, support vector machine, right? So now these are another application which is spam detection. It is detect the unsolicited and unwanted email to prevent those message from getting to our user inbox, something like that. There is a spam and virus or your mail all over yours collectively there, and when it is go through this server, then automatically it is classified and it is come to our inbox, and the other will go to the spam and trash or virus, whatever it is separated automatically. Okay, so uh, that's all for now. So now I'm going to show you that very small two programs using SVM. So one is for the linear, another is using a kernel. So thank you for watching this. Thank you.